Hey everyone! Thanks for joining us for the next episode of our Spotlight on GitHub Advanced Security series. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand within 48 hours, right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenter for today. Michael, thank you so much for joining us.
Thanks, Anna, and thanks everyone for joining. So, quick introduction. My name is Michael Edens, and I'm the co-founder and CEO of Fianu. And Fianu is an automated governance platform, which is largely what we're here to talk about today. But more specifically, we're here to talk about policy and the missing link to continuous compliance. So we'll start here with the problem. And the problem is that DevOps left regulated industries behind. And the culprit is manual governance. And so in a regulated environment, in order to maintain an adequate risk framework, organizations resorted to manual governance processes that slow down a release cycle, kill productivity, create a lot of downward pressure on developers, and a huge risk of failing audit. And of course, leaderships face penalties for errors and omissions. But what this has led to is, instead of fast features being delivered in continuous delivery format, what's happened is organizations and developers, more specifically, have resorted to batching larger changes together in order to absolve the overhead of manual compliance. And the cost of this to organizations is pretty high. So if we look here at the organization size going from extra small all the way to extra large, with the median number of annual production changes, let's assume 72 hours per change, which is the ITSM change management average, at an $80 hourly rate. It leads to a pretty exponential growth in cost just to perform manual governance in order to release to production. So how did we get here, right? Let's look here at an example. So this is the Office of the Comptroller of the Currency, which is referred to as the OCC, and it regulates large banks. And this is just an example, but it effectively says, this guidance says that you need to have a risk management framework in place for technology change. So that's referred to as the change approval process, path to prod, definition of deployable, go live criteria, production readiness review. All of these are synonyms for what's required to ship. And what it's referring to is the life cycle, everything from planning in Jira to code commit, build, all the way through release and validation. And the hidden process here looks like this. So in the blue boxes are engineering tasks, and the white boxes are administrative tasks. And these are all of the tasks that are required to ship to production in one of these regulated environments. And so if we plot this along a 30-day cycle, which is on average how long it takes to complete this process in a regulated environment, you'll see this is how the tasks are distributed in terms of the time that they consume. Obviously, the administrative tasks are occupying the majority of that 30-day time window, right? These tasks right here, these are non-engineering requirements to ship. So you're probably going to ask yourself, well, what is required to ship? And it's really simple. It's proof that you did what you're supposed to do. So how do I know what I'm supposed to do? Well, let's look at a few examples. So in this slide here, you'll see that we've got three examples, one from the Monetary Authority of Singapore, one from the Office of the Comptroller of the Currency, and one from the FDA. And all three are guidance documents that explain what's expected as far as just security testing. And so the Monetary Authority of Singapore says it's essential for the financial institution to establish a comprehensive strategy to perform security validation testing. You can use a mixture of static, dynamic, and interactive testing methods to validate the security, right? Pretty straightforward, but a little vague. My favorite one is the OCC, which says scanners and other tools can be run continuously. Alternatively, they can be run periodically. And what does that mean? Right? So this is how it goes. This is the conversation and how it goes. So the company says, hey, what does that mean? The regulator says, make sure you don't allow vulnerabilities into production. Well, how do I do that? That's up to you. Should I do SAST, DAST, IAST, SCA, and container scans? We don't tell you how to do your job. Well, how will I know if I'm successful? They ask. And the regulator says, your auditor will tell you. And that's how the conversation goes. And what's really expected here is that in the business process of technology change, and more specifically, custom software development, the organization identifies risks. Those risks have mitigating controls, and those controls become requirements through policies. These policies are supplemented by procedures which document how development teams are supposed to collect evidence in the form of attestations, which then gets turned over to the auditors. So we're going to focus on these parts here, because these parts are the opportunity for what we call automated governance. And as I mentioned before, Fianu is an automated governance platform, which means that, in short, Fianu does attestations, compliance gates, policy management, and software asset inventory. And we're going to focus on software inventory here just for a second and drill down into properties, because properties are a part of software inventory, but pertain specifically toward policy management in a large enterprise. So we're going to drill all the way down to the lowest level, and I'm sure this will be sort of elementary for many of you joining today, but we're going to build up from here. So let's start here and say that this is a software artifact. And a software artifact is produced from a repository. And different repositories produce different artifacts. One's yellow, one's blue. And some repositories produce multiple artifacts. We call these multi-module repos or mono repos. So what do you do when you have a lot of artifacts produced from a lot of different repositories? How do we manage that at an enterprise scale? Well, it's really simple. We just put a box around it and we call it an application. This one's called the online banking application, and it consists of 395 components, and it's given the app code OBA. So now we've stacked a couple applications on top of that: mobile notification engine, event streaming platform, digital client onboarding. And so what do we do when we have a bunch of applications with a bunch of repositories and a bunch of artifacts? Well, we put a box around it. We call this a portfolio. This is the digital services portfolio, and it consists of 5 applications. All right, so here's our digital services portfolio. And when we have a bunch of portfolios, we call that a line of business. This is the retail bank line of business, and it has 7 portfolios. And so when we have a bunch of portfolios, we get a view of the entire company, which is way too many to count. So the question is, who knows what? So if we start at the applications, that's stored in the CMDB, the Configuration Management Database, which is how most large enterprises categorize their software asset catalog. The portfolios, line of business, and the entire company can all be viewed in this CMDB. The repositories exist in the SCM platform, so it knows about those. And then the artifacts are stored in the package registry. So one of the things we're going to talk about today is the connectivity between all of these, which is some of what Fianu works to achieve in service of allowing organizations to set policy across them. So let's go back here to the portfolio. And if we drill all the way down and unpack these applications, we're going to end up back to our online banking application. And in an environment where manual governance is the standard, the application level is the smallest organization unit that can be used for governance, because it's just about all the human brain can handle. The problem with that is that if you apply policies at the application level, you're missing the item that actually introduces the risk, which is the artifact. So when deploying to production, you're deploying artifacts. Artifacts are what introduce risk. When you update your software and you ship new artifacts to production, you're adding risk. And so when organizations create policy, right, and let's go back to our security policies that we mentioned before. Let's say we have a policy that says this artifact must have blank and a score of blank, right? That's not how policy is written in a large enterprise, right? What's really happening, and this is a real policy, is any software that is risk tier 1, exposes API endpoints, and is internet facing must perform an IaaS scan and show 100% route coverage and zero higher critical vulnerabilities. So how do you adequately apply policy based on that criteria? It's harder than it seems. It's very simple to capture the results of an IaaS scan, measure 100% route coverage and zero higher critical vulnerabilities. But how do you know which artifacts this policy applies to? Well, it kind of requires that you have the ability to say risk tier 1 is pulled from the CMDB. API endpoints are detected in code changes and validated at runtime. And internet facing, for example, would check that you're deploying to a cluster with a namespace with an ingress that's configured for external internet traffic. So capturing all of these, what we call properties, is what allows you to administer this policy that dynamically applies to software that's considered in scope based on the properties that each artifact has. And so what that is what we call automated governance. And as I said before, automated governance is attestations, compliance gates, policy management, and software inventory for this part of the software development lifecycle. So from planning in Jira to code commit all the way through release and validation. And what Fianu does is it captures the events that occur throughout that lifecycle, it measures them against policy, and then produces attestations. Each attestation is determined to either be passing or failing. And attestations are the unit of measurement that's turned over to auditors. So what that looks like here is that, let's take this one example of unit test code coverage. It's a common one that every organization employs in some capacity. And what we're doing here is we're looking at the raw event data that comes from the tool that measures code coverage. We're comparing it against a codified, predefined policy that says the minimum required coverage is 80%. We compare those two pieces of data using a rule written in Open Policy Agent that says that the coverage is greater than or equal to the policy minimum. And then determining pass or fail, we then digitally sign the resulting attestation using SigStore, which is stored in an immutable ledger. And what that provides us is a dashboard that looks something like this, where the green badges are passing, the red badges are failing, and then we have in progress, not found, warning, or not required. And so this is what the Fianu dashboard looks like, and this is what we're about to demo now. All right, so you can see here on my screen, this is the Fianu dashboard. And at the start of this demo, I'll say that everything in Fianu is accessible via API. But the dashboard is a great way to visualize all of the data that Fianu captures. So at a high level, you can see that we have all of the applications as they're categorized in the CMDB. And what Fianu is capturing is the real-time compliance status for each of these applications for all of the controls that are required to ship. Now, as I mentioned in the presentation before, what's really important are the individual artifacts and components that are deployed to production. So let's go here into Digital Bank Experience, and we can drill down and view the real-time compliance statuses on each of the components that are required to ship for all of the controls. And we can drill down here into Digital Bank Experience, and let's pick one of these components. We're going to pick XD Banking App. So you can see here for this code commit, XD Banking App is failing on one control and is grayed out on another control, which is not required. We're currently blocked from deploying to production, but we're okay to ship to QA because the required controls for QA based on gates that our organization has set, we're passing on all of those controls. But we're blocked from deploying to production because right here, this unit test coverage control is shown as failing. So let's inspect this. So this is our attestation on the left-hand side, and it contains all of the evidence required to explain why unit test coverage is failing. But what we're really looking at here is the overall coverage of 78%. When compared against our policy minimum of 80%, you can see that it's failing. So you may ask, well, how did we get this policy? Well, the policy starts with a company default. So at our organization level, we set a default coverage policy of 50%. All software in the organization must have a minimum of 50% code coverage. But because XD Banking App is considered high risk, which is risk tier 1, it's required to meet this coverage threshold of 80%. So that's how we arrived at this 80% minimum, which is failing when we have 78% overall coverage. Now, when an auditor asks, well, that's great, we know all this information, but how do I know that it's authentic, right? Each one of these attestations is digitally signed and stored with SigStore, and we can actually view our SigStore Recore ledger entry right here. But then let's say your auditor isn't satisfied. They know that you're failing code coverage control with 78%. We know what the policy is and how we arrived at that policy. But they want to know where this data came from. Well, baked into each one of the Fianu attestations is what we call the chain of custody of evidence. So starting left to right on the bottom bar here in chronological order, we started with the raw webhook payload that came from, in this case, SonarQube, and it tells us really nothing other than a scan occurred. Then we performed enrichment to capture the entire SonarQube report and all of the metrics. And then we compared it against policy to produce a pass or fail attestation with just the information that's required for this control. So that's how we arrived at a failing status for the code coverage control. Now, the last thing that you may ask is, well, how did we perform that evaluation? So Fianu comes with out of 40 out-of-the-box controls that support over 60 third-party toolchain integrations. So if you think about the integrations being the toolchain platforms in your stack, Fianu supports over 60 out of the box. And using those 60, we have over 40 out-of-the-box controls that make up the baseline control packages in Fianu. But what if I needed to customize my own control? Well, I'm going to show you how you can do that by going here into the Fianu code coverage control. And we're just going to edit this one just to save time and show you how it would work. So you would add a name, the display key, give a description and link to your official policy documentation. Then we put it into a domain and collection. So this is for role-based access control. We want to put this in the static code analysis collection and assign an owner to it. Then here in the source and domain, what we're looking for essentially is what event streams do we want to subscribe to, where when an event comes in, it gets evaluated against policy. So in this case, we're going to consume a SonarQube static code analysis scan. But let's add one more and say that we also want to consume JUnit test reports. Put that into the compliance controls domain as well. The attestation results were required to either pass or not found, which is no evidence of the control happening. But we're also going to add a failing control here as well. And then we define our policy template, which may look familiar. And it says, effectively, the overall coverage minimum is a numeric value. Now, a bunch of other configurations, but now we go down here into our evaluation criteria. And this is where we define our rule written in Open Policy Agent. And for those that aren't familiar, Open Policy Agent is a domain-specific language for expressing policy and evaluating policy. And what we're really saying here is that the definition of what it means to pass code coverage is if your overall coverage is greater than or equal to the policy minimum. And we have a sample policy that we filled out based on the template that we defined. So here with a sample event stream payload that comes from a Sonar Cube scan, in this sample policy, we can actually test our control. You'll see that we're failing. We can test against different policy cases here. So now we're passing. Right? So when we're done, we can actually commit this directly back to source code or just do it through the Fianu UI. But all of this can exist in source code. All of the configurations with Fianu can exist within source code. So let's go back here. That's how the control is defined for code coverage. Right? That's how we're evaluating and the event streams that we're going to consume to perform that evaluation. So now we're back to a scenario where we have this code coverage policy, and a new policy was created recently by the risk management department that said if you're risk tier 1 or higher, you need to have a minimum threshold of 80% for your code coverage. Because it's elevated risk, you need to meet a higher threshold. But that's blocking us from releasing to production. So as the team lead for XD Banking app, let's say that this is a legacy code base. This is 8 years old. It's got tens of thousands of lines of code, and there's no way that I'll be able to boost my coverage in time for my upcoming release. What are my options? Well, the first option is to request a policy change, and that's what we're going to do here. So I'm going to go here into the policies console, and I'm going to identify the high risk coverage policy that was created by the risk management department. And it pretty much says that if the asset properties say risk tier 1, we're going to require an overall coverage of 80%. I don't want to create a new policy. I just want to add a variation to this policy that says if the asset was created on or before January 1st, 2019, so let's say a little over 6 years old, we're still going to require this policy. We're going to leave the new coverage at 80%, but we're going to drop the overall coverage to 70%. And I'm going to add my justification as developer and say that legacy code base need more time to remediate. So once I click commit, this will get routed through our standard approval workflows. And you'll see when we go back here to XD Banking app, we are now going to recompute a new attestation, and keep an eye here on the gates so that when the new attestation is generated against the new policy, it shows that 78% is now passing, and we're good to go for our production release. So just to recap what we did there, we had a policy in place for any software that was considered risk tier 1 was required to have a minimum code coverage threshold of 80%. Given that XD Banking app is what we call a legacy code base, we requested a change to policy that lowered the threshold for code bases older than 6 years down to 70%. We provided a justification, and it was approved. So that policy change went into effect, which now made unit test coverage control passing, and we're good to ship to production. Now, it's great. We can create all these policies directly within Fianu, but wouldn't it be nice if we could create them directly in GitHub? And that's what I'm going to show you next. So let's go over here to this CodeQL control, and you can see that currently it has one high vulnerability, but it's gray. It's not red. And that's because our AppSec team onboarded to CodeQL about 4 or 5 months ago, and they've been running it in an observational state, meaning they're not enforcing any policy. They're just capturing data on the vulnerabilities in each piece of software. So right now, technically, we're failing against our policy, which says you're not allowed any high or critical vulnerabilities. But the policy isn't required. So it's shown as gray, and we're allowed to ship anyway. But let's say that I'm the director of application security, and I would like to start rolling out enforcement of CodeQL. I would like to start blocking teams from deploying to QA and production if they have a high or critical vulnerability in their code base. So let's go here and see how we can do that. The first thing I'll highlight is that Fianu captures a bunch of properties from a variety of different sources, directly from the source code, the runtime environment, and from the CMDB. So you can see here, we know that this piece of software is internet facing, exposes API endpoints, and we can see those API endpoints. We know the language it's written in, we know the line of business that it belongs to, and we also know the CIO for that line of business. All of these properties that Fianu is capturing are stored in Fianu, but also synced in real time to the GitHub repo properties. So let's go here into the XD banking app code repository. You can see we've got a copy of the dashboard that lives directly into the README. And we can also add this into code reviews as well. Anywhere that an HTML image can be stored, we can add the Fianu dashboard. But what we're really interested in are the custom properties for this repository. So you can see here in XD banking app, we're storing properties that are captured in Fianu. So if properties captured in Fianu, it syncs to GitHub repo properties. If a property is added in GitHub repo properties, it syncs to Fianu. And so we can see here, Fianu internet facing is one of the properties that's stored at this repository. And that allows us to go here into repo rules. And what we're going to do now is in our repository rules, we're going to create a new branch rule set, and we're going to call it CodeQL internet facing. And what we're going to do is we are going to target repositories dynamically by their properties. So we're going to add a property target, and we're going to select Fianu internet facing. We're going to add that target, which will effectively filter all of the repository properties that have the Fianu internet facing property. And for all of these repositories, we are going to require code scanning results for high or higher. So any high or critical vulnerabilities. Okay? I'm going to create this rule set. This rule set was created. And just to recap what we did, we have a CodeQL attestation that is not required because we're running it in an observational state. But we want to roll out enforcement in a phased approach that starts by blocking internet-facing software from deploying to QA and production if they're failing the CodeQL control with a higher critical vulnerability. So now that we've created that rule set, we're going to recompute the attestation and keep an eye here on the gates for XD banking app. Once this recomputes, you'll see that we're now blocked from deploying to QA and we're blocked from deploying to production. So now let's put ourselves in the shoes again of the development team. So I'm back to being the technical lead for XD banking app. And our security team rolled out this new policy starting to enforce CodeQL for internet-facing software. That meant that we're now blocked from deploying to production, but let's say that I have a release coming up on Friday. So if we look here in the bottom left corner, we can see that the current version of the code base, which is the one we're looking at, is running in the QA environment. It's version 2.4.0. If I go over here to my releases tab, I can see that we have DBX release 2.4.0. It's got all of our Jira stories linked, and it also has all of our assets that are being deployed in this release. So what we're looking at here is that the gates that we just showed before were blocked from deploying to production and QA because CodeQL is now one of the required controls. And it's failing, of course, with a high vulnerability. So what are our options here? We have a couple options. We can either request a policy change, but we don't think that's necessary in this scenario because it's for a release that's coming up on Friday. So we don't need a policy change that will last in perpetuity. We can also add an annotation just explaining why we're failing. But what we really want here is a temporary exception to release this piece of software on Friday because we don't want to have to go and rebuild the application, test it in QA just to get it deployed to production. So we're going to request an exception. And the way that we'll do that is by going here into our code scanning alerts in CodeQL, and we can see our finding here. And what it shows is that we have the JS missing rate limiting finding. Now, we have the option. We can either use the Copilot autofix, which will just remediate this vulnerability and remove it so that we're passing with 0 high and 0 critical vulnerabilities. But let's say that we don't have time to get this all the way PR all the way merged, deployed to dev, deployed to QA, tested, and then to production again before our release on Friday. So we're just going to grab this JS missing rate limiting rule ID. We're going to go here into Fianu, and we're going to request an exception. And the exception is for a high vulnerability with the JS missing rate limiting ID. And as a developer, I'm going to say, I need my full 14-day SLA. I promise I'll fix it. Now, once I add my justification, our AppSec team has created an auto approval rule, which said that if we're in just a few days of the release, we can submit an exception and we'll do that. And so you'll see that this gets auto approved. And now we are green for our production deploy and we're green for our QA deploy, although we're already running in QA. But most importantly, we're now allowed to ship to production. And so with our release, we're able to now ship to production because we were able to request a temporary exception to policy. So I just want to recap what we did there. So here in the XT banking app, we had a failing control for CodeQL, which was then required by the AppSec group. And they wanted to roll out a phased approach, starting with internet-facing software. So using the property of internet-facing, they were able to create a repository rule that created a Fianu policy that now switched CodeQL from gray, not required, to red. And then when we went to the release, we were able to request a temporary exception just for the release that would allow us to ship to production. So that's how we can perform policy evaluations and policy application using software asset properties with GitHub and Fianu. Great. So that's what we have here today. Thank you everyone for joining. Let's look here in the comments. It doesn't look like we have any questions, but if you would like to reach out to us and see more, please go to fianu.io. And we would love to show you a little bit more about how Fianu can apply to your organization and how you can use a properties-based approach to administer policy using Fianu and GitHub. Thanks, everyone.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.